Welcome to NASA Edge.
An inside and outside look at all things NASA.
You know, Franklin, we've covered a lot of launches over the last few weeks. JPSS-2, Artemis, and now SWOT, the Surface Water and Ocean Topography Mission. Very important Earth science mission for the agency.
Yes, Blair, this mission is all about water, not just the water around where you and I live, but water around the entire planet.
You make an excellent point, Franklin. This mission involves many international partners. In fact, the spacecraft was built in France. We'll learn more about that on the show.
And then I'll talk to Jason Jagman from LSP, who will talk to us about the Falcon 9 launch vehicle and the SWOT spacecraft and where we are in the countdown to launch.
In fact, let's go take a look at the rocket now, and when we come back, our first guest. Joining us now is Tahani Amer from NASA headquarters. Tahani, thanks for being on the show.
I'm glad to be here.
Well, one of the things that's interesting is you're technically the program executive for SWOT, and I don't think we've ever interviewed a program executive. What is a program executive?
So the program executive's function is to ensure the project is successful in all levels, from a technical perspective, from schedule and cost. I call it the person that puts the puzzle together and makes sure the glue is connected to make sure we are successful. And this is a function that a lot of my colleagues and myself do at headquarters, and to inform our stakeholder, to be the conduit for the project, and to ensure the project is successful.
Well, considering the responsibility, thanks for taking time to be on the show. Now, tell us, what is SWOT? Because, you know, I thought SWOT, it was going to be like the SWAT force, but this is something very different and very important for NASA. What is it?
So SWOT is the Surface Water and Ocean Topography. It is a very unique mission, and it's first of its kind. We'll be surveying nearly all surface water in Earth, from the ocean to the land, and be able to understand global picture of the water cycle, and be able to help us address transformative question about climate change, our water cycle, how is the ocean absorb the carbon and the heat, and where is the water is and where is going.
And there's some unique instruments on the spacecraft. One in particular, can you tell us what that is?
Yes, there is one particular instrument, I call it the heart of SWOT, which is a Karen model. The Karen instrument. The Karen instrument is the Ka-band radar interferometer, and this is very unique instrument that's really a new technology that we have in SWOT, and we'll be able to measure. It has an antenna that will send the pulse to this water surface and return that pulse and be able to calculate. And it's big, very wide swath, which is about 50 kilometers, which is very interesting, be able to see a bigger and more detail of the ocean, and we'll be able to measure rivers, lakes, and any wetlands.
It's funny, in the last few weeks, we've seen JPSS-2 launch, and that had Loftus splash down in the ocean, and then we saw Artemis just splash down the other day. It seems like it's very important for us to better understand these oceans, since we probably have a lot to do with them from a NASA standpoint.
Of course. Well, let me tell you, I call water unite us all, because water is very important and very limited resources. And be able to understand our climate changes, we need to understand the water cycle, because it's all connected. From the ocean to the land and back to the ocean. It is one connected system, and water is very unique.
Now, this mission also features several partners. Can you tell us the partners that NASA's working with for this mission?
Oh, wow, yeah. It's been great partnership with the French Space Agency, and we've been partnering with them for almost 30 years. And then we have the Canadian Space Agency, we have the UK Space Agency, and we have multiple contractors like the Thales team and the SpaceX team. It's really very international mission that unites not only all of us with water, unite a great partnership.
I'm looking forward. We have some guests on the show later that are from those partners, so looking forward to that. But I understand you have a personal connection with this mission. Tell us about that.
Yes, so it's kind of interesting. I am originally from Egypt, and my father, bless his soul, he worked in the high dam for the Nile River in the 60s. And here you go, about what, 40 years later, his daughter is working to watch the Nile River from space with SWAT. So that is really exciting for me.
And I tell you, this is what's exciting about NASA, is taking these unique looks at different area and aspects of the planet. Because as you said earlier, we do need a better understanding if we're all going to live on this planet and use these resources properly.
Yes, yes, of course. It is very important to understand the limited resources of water, and two, how is that affecting the climate changes, and be able to predict, have better model for floods and weather, extreme weather and droughts that affect all of our life. And SWAT will be able to give us all this data and help us have a better model and prediction of all this activity.
Tahani, thanks so much for being on the show and your work on SWAT.
Thank you very much. Go SWAT.
Awesome. Now, Franklin had a chance to talk to one of the persons who worked on one of the instruments, that Karen instrument on SWAT. Let's check it out.
We're here in the Von Karman Auditorium at the Jet Propulsion Laboratory in front of a model of SWAT. And I'm joined today by Daniel Fernandez, who is the Karen Instrument Manager. How you doing, Daniel?
I'm doing great, thank you.
Tell us, what is the Karen radar?
So Karen radar is a interferometric radar. That means that it is it looks from 2 vantage points, and it's able in this manner to triangulate a point on the surface and make a height measurement. And we use that to measure the height of the ocean and any fresh water on Earth. Very, very small levels of accuracy, centimetric levels of accuracy.
And you said centimeters. Now, radars in the past have been able to give accuracy in
a few meters, I would say. The best example we have is the shuttle radar topography mission, which mapped the entirety of the Earth over a period of 11 days back in the early 2000s. And that radar measured with an accuracy of a few meters.
Now, you've been working with radars your whole career. Now, how special is Karen versus radars of the past? You said that the measurements have gotten a whole lot better, but is that a really big difference?
I would say so, yeah. I think what sets this radar apart from any previous radars, I think, is a combination of things. Number one, just the sheer size. So we have very large antennas, about 15 feet long antennas that are separated by like 30 feet away. So they use deployments and all kinds of mechanisms in order to be able to deploy this in space. Because of the accuracy, we have to transmit a lot of power. This radar transmits 1,500 watts down to Earth so that we are able to see the echoes coming back from the surface of the water. And then the third aspect, I would say, is the overall stability of the system in terms of knowing where it is in space and where exactly is it pointing at. So it goes to, again, you need to know where the spacecraft is to within centimeters, and the angles are also very, very demanding, milli-degrees types of accuracy. So those characteristics set these radar apart from pretty much any other radar that I think has been flown to date.
Now, this radar is a combination of radar technology that has evolved over the years. What specific measurements will you get from Karen that will, say to you that, wow, this is truly a special instrument?
The most important measurement that I think this instrument will provide is the height of the water. And of course, the ocean is a key element in understanding the climate. But to me, personally, I think that where it will really provide a unique knowledge that we don't have today is just in terms of the fresh water. So of course, fresh water is something that is critical for us as a growing population. And we don't have any good understanding of how much water there is and how is it changing. So to me, having a global picture of how that looks like and trying to be able to understand whether it's diminishing, whether it's growing, whether it's stable, it's paramount towards understanding what our future generations will have to deal with in terms of freshwater access.
Daniel, great information, and we look forward to getting extraordinary data from SWAT.
Thank you very much. I am as well.
Joining us now is Christophe Duplé from Thales Alenia Space.
Yes.
So I really worked hard at this. I was expecting to be corrected because I have not been able to do this well.
You're right.
But it is great to have one of our international partners here. Tell us, what is your role with SWAT?
Alors, me personally, I am a project manager for SWAT at Thales Alenia Space. I am in charge to manage all the activities of Thales in order to bring the satellite in time with the correct performance, in the budget, with marvelous teams of engineers we have.
And this was a unique situation in terms from NASA's perspective, because I understand that the spacecraft was built in France under your direction.
Yes. So Thales Alenia Space has a major role in SWAT. We are the main industrial partner. In fact, we design, manufacture, and build the platform. What we call the platform is a service module, which will give all the function to the payload in order to make the mission possible, like power, propulsion, avionics, guidance, telecommunication with the airs. And so after that, we received the payload in Cannes in June 2021. And after we met the payload on the platform to make a spacecraft, and we are in charge of all the AIT is assembly, integration, and test of the spacecraft, including the launch campaign.
Now, one of the things I'm wondering, obviously you had some folks from NASA over there helping during that process. So what were some of the big challenges of getting SWAT ready for launch?
The first one was to make work together three different entities with a different culture, different way of process, different way of working. There was GPL, CNES, and Thales Alenia Space. So the first challenge was to make all the people ready and in the same direction to make the integration of spacecraft and deliver in times. The second challenge was COVID.
Yeah, of course.
So the COVID was complicated. So during our integration of platform, and again, on the other side, on GPL side, there was COVID during the integration of payload. It was complicated to be in time. And after, when we have mated, it was some special procedure to apply. It could be make the planning difficult, but we succeeded.
Tell us a little bit about how it is to work with so many different partners on a mission like this, from NASA to our European Space Agency partners and all the others that have participated in this.
Yes, well, for Thales Alenia Space, it's a long story on oceanography with CNES and GPL. It started in 1992, I think, with Topex Poseidon, and we built JASON 1, JASON 2, JASON 3, and
yes.
It's now SWAT. It's on the same schematic and organization with two main agencies, NASA, GPL, CNES, and Thales Alenia Space.
Awesome. What a complete picture of this mission. A lot to do, a lot of important things going on. Thanks so much for being on the show, Christophe.
Thank you.
I had a chance to talk to another team member from SWAT earlier at JPL. Let's check it out. We're here at NASA's Jet Propulsion Laboratory with Nasser Shahat, who's the payload systems engineer for SWAT. Nasser, tell us what it means to be the payload systems engineer. What does that involve?
So the payload system engineer needs to understand all of the interfaces within the payload itself, so across all the instruments, and also with the bus, which is a subsystem delivered by our partner, Thales and CNES. When we actually assemble everything, it's very critical to understand all the interfaces, all of the fault protection that are being implemented. That was a big part of all of the qualification that we did actually in France. That's finding all potential issue that we could have, or even better, avoiding any potential issue we could have when we integrate both of them.
And of course, that's more challenging when you are dealing with an international partner and people from different backgrounds. How was it to work with your international team?
It was actually great. We had a very nice experience. It was about a team of 10 to 15 engineers being there at the same time, working all together every day. We had very, very long days sometimes, especially during TVAC tests. We became very, very close for that reason. Some of them didn't even know each other, even though we've all been working for more than 10 years on this project. So it was very great to actually being on the same site all together, working with partners that comes with new challenges, the difference of cultures, different rules that we have to follow. So it's different.
And not to mention the language barrier. How did you guys handle two different languages?
Yeah, so actually I'm French, so I can speak French, so that was
That's
not really
cheating.
a barrier. Exactly. So there was a lot of very funny, at the beginning at least, when we were still here. They will speak sometimes in French, not knowing that I was French, and then I would jump in and say, yeah, actually the answer is that, before they would even ask in English. So that made some stories.
But I guess at the same time, that is a real advantage, and sort of, since you are working together so much, breaking down those barriers that might slow you down.
Yeah, absolutely. Is that so sometimes, I mean, when I say differences of culture, it's also the different languages. So it's not always easy for us or for them to say it in a different language, especially technical conversation. So it's nice to have the ability to tell them, oh, maybe you want to say it in French, and we'll see if we understand better. That happened more than once, and that worked out pretty well.
Awesome. Now, did you work on any specific element of the spacecraft along the way?
Yeah, so I had actually many roles over the 10 years on SWAT. I started as the antenna engineer for telecom. So we developed a new antenna that allows to do a high data rate communication, 620 megabit per second with a low gain antenna, which was quite a challenge. Then I worked as the EMI/EMC system engineer, making sure that all of the instruments were compatible with each other, because we have transmitter on one hand, we have receiver on the other hand. Some of the receivers are very sensitive, so we need to make sure that they can actually work at the same time without interfering with each other. Then I worked as the product delivery manager for the high power amplifier on the Karen instrument, which was a whole beast on its own. And then my final role, which is my current role, which is a payload system engineer, and I'm also the cognizant engineer for the payload.
I guess a better question would have been, what didn't you do on SWAT?
I didn't do a lot of things. Obviously, it's a teamwork with a lot of talented people working on a project, and that wouldn't be possible with all the talents that we have here at JPL and also our abroad partners.
Joining us now is Christine Jabara, as a mechanical engineer for SWAT. Christine, thanks for being on the show.
Thank you for having me.
Well, I got to tell you, I've talked to a lot of different people from SWAT today, lots of different companies, different partners and things like that, but you have worked with this team for a long time. Tell us about your experience working on SWAT, in particular over in France when it was being assembled.
Absolutely. So I've been working on the project for years now, and I've been lucky enough to work on a diverse and large team at JPL and across the ocean in France to assemble, build, and test SWAT in various capacities. We've gone through vibration testing, thermal vacuum testing, electromagnetic interference testing, and helped set up the satellite to go through those tests successfully and dealt with all those problems.
It's almost like it's easier to answer what you didn't test.
Oh, we've tested everything.
Okay. I mean, it is kind of amazing, all the steps you have to go through in this process. And I'm wondering, if you were over in France, how was it dealing with the language barrier and cultural barrier?
Actually, it was really interesting, and it added a new layer to our work. We got to see how the French build satellites, how our partners build satellites, and we got to bring our own processes over there and collaboratively figure out the right way to test SWAT and make sure it'll work once it's in space.
And of course, all this happened in the midst of a pandemic, which added challenges. How did you guys handle that?
Well, it added a new layer of complexity to working in a clean room. Before we went to France, actually, I was doing operations in a clean room with our technicians, but we were working on hardware that the French have contributed a lot to. So actually, we would get on Zoom, we would get on a web conference with them, and we'd be working on the satellite, and they'd be watching with a camera. And there was actually a time where we were installing a thermal blanket, and it was a French thermal blanket that they had designed, and if the pandemic hadn't happened, they would have been there to install the thermal blanket, but we were working with them to do it over the course of the pandemic. And they had a paper doll in France to assemble it, and we were in the clean room, and we had some very skilled technicians also assembling it, and collaboratively we were able to get that thermal blanket installed.
What's amazing to me about a situation like that is just the ingenuity you have to all of a sudden tackle what would be, I don't want to say a simple procedure,
sure,
but one that could more easily be handled by those installing it, to now having to do it remotely. And I got to imagine that was at least a little more stressful trying to get things done.
It was a little more stressful, but really it just required us to understand each other's designs and systems that much more. And once we were in France, it was actually great because we'd already built relationships over the course of the pandemic, and working in person was that much smoother.
Wow, it's really impressive. And then, of course, you guys packed up the spacecraft and you've been over here, but you didn't stop work once you got here. You had to sort of check things out here as well, right?
Absolutely. So we were in France for a little over a year, and now everyone, the whole team, came over here. And for the last few months, we've been doing the final last checkouts, crossing our I's and dotting our T's, and putting the satellite on the top of the rocket.
How was it for you after transporting the satellite over here, wondering like what could have happened during transport? I mean, you had to. I know you were prepared for it, but
Sure.
it had to provide some anxiety.
Yeah, absolutely. We put the satellite in a box after a year of careful testing and assembly, and then you want to make sure that it comes out the same way. And I have to say, the shipping container we put it in is an engineering feat of its own. So we spend a lot of time building and testing the satellite, but they also do the same thing to the shipping container. And there's some experts from Thales Alenia Space and JPL and our military that helped get it over here safely.
It's funny, we talk about partnerships a lot, but clearly, when you think of this kind of effort, it's really clear how important that is to make sure your mission is successful. Now, one thing I wanted to say, I understand you mentioned this, that you've done a lot of testing
Sure.
with the spacecraft. Can you tell us a little bit about the uniqueness of testing a satellite like this and getting it ready for space?
Absolutely. I've done a lot of work on the Karen instrument, specifically on the deployable antennas. And the deployable antennas are 5 meters each in length, and they're designed to work in space. They're not designed to work in a clean room. So we actually do testing. We do all sorts of deployment testing to make sure that they'll work once they go to space. But since we're on the ground, we have to use extra careful ground support equipment to make sure we're handling the hardware safely. And so one thing I've done is I've led what we call the first motion test. And what we do is we do a small deployment of the antenna just to make sure that the whole thing works.
Right, like a mini version of the same thing.
Absolutely.
Yeah.
And we've done this in thermal vacuum environments. We've done this in the clean room environment. We've done it at JPL. We've done it in France. And I've been very lucky to be part of the team that does it. And so what's often hard, though, is describing the deployments and showing people exactly the sequence of events.
Sure.
Yeah. And so we sometimes do a little bit of a dance to put it together.
I'm curious about this dance. I understand that you made this dance kind of popular.
Absolutely. Oh, I don't know if I made it popular, but when we're in the clean room talking about the different phases of the deployment, we're like, which one comes first? What happens where? Because the antennas are actually so large, we can't test them all together, and they're so large and complex, so we can't test it as one system on Earth.
All right, I won't provide a music soundtrack for this, but could you demonstrate the dance?
Sure, okay. So can you hold the microphone close
absolutely.
to me?
Yep, I've got it.
Essentially, the antennas go to space packed up like this, and then the first two deployments are kind of on each side are the booms or the masts. And so it goes up like that,
Yeah.
and then down like that. And so the booms have now deployed, and then the reflectors, and my fingers aren't long enough to do this,
Yeah.
but the reflectors actually pop out so you can see my thumb and my pinky right there. And so that's when the DAAs or the deployable antenna assemblies deploy, and they're ready to do real science.
And not only science, but social advantage. This would be very fun at parties. If you have your SWAT parties, be sure to do the deployment dance. I won't do it for my own personal reasons. I have no rhythm. But fortunately, we actually happen to have animation of this process.
Oh,
Not the
great.
dance, but the real action of the satellite. Thanks for being on the show, Christine. We're going to take a look at that animation now.
Absolutely, thank you.
And when we come back, Franklin will be joined with Jason Jagman of LSP to talk about the rocket.
Right now, I'm joined by Jason Jagman, who is the Mission Integration Branch Chief from the Launch Services Program. Thanks for joining us, Jason.
Thank you. Thanks for having me.
Right now, you're the branch chief, but early on in your LSP career, you were a mission integration engineer. Tell us a little bit about that job.
Yeah, the mission integration engineer is really the technical person that works with the customer, in this case, our Kinesis and Thales customer, to gather their requirements and really be the technical focal point for the mission and lead the integration team through the entire processing of the mission. So I was fortunate enough actually to be the integration engineer early on SWAT, and actually was part of the team to actually develop the requirements that actually went out to purchase and buy the Falcon 9 that we're flying on today.
This Falcon 9 has to roll out and it has to go vertical at the launch pad. Can you tell us a little bit about that process and how that works prior to launch?
Yeah, I mean, well, after we did all the spacecraft testing and actually did all the encapsulation activities, so mating the Falcon 9 to the encapsulated assembly or the SWAT spacecraft, in this case, is really that first step. And then really putting the vehicle onto the transporter erector. As we did that, well, actually they happened in reverse order, but really the vehicle got mated and then really ready to do the electrical checkouts, the things that we need to do to say, hey, we're ready to roll out, we're ready to get the vehicle in a good position to get it ready for launch. So really, we executed the static fire this past weekend, which was a really big milestone. We moved that forward to Friday evening. The SpaceX team, the NASA team worked really hard with the customer team to really execute that, to beat the weather. We had some bad weather this weekend because apparently winter was coming. So we had to get out ahead of that and really get to the point where today we're getting rollout and getting that vehicle rolled out. We just had the launch readiness review today in order to allow that activity and get to the point where we're going to roll out. We're going to mechanically mate into the launch pad, also do the electrical hookups and all the connections for all the fluids, what have you, and get ready to go vertical with all the hydraulic activities that are going to lift the transporter erector and get it ready for launch.
Are there any benefits to working on the Falcon 9 in the spacecraft while it's horizontal to the ground versus being in a vertical configuration?
Yeah, I mean, from a vehicle perspective, there is a lot of advantages that SpaceX does to execute their processing of the vehicle in the horizontal position. They really don't have to worry about a tower structure or anything, and they can rotate the vehicle to work on the parts they need. From the spacecraft perspective, really the spacecraft is in a vertical configuration all the way to mating, encapsulation, and then it gets broke over in the horizontal position just prior to the mating activity to the vehicle itself.
So after the Falcon 9 has been taken vertical, what are the next steps in preparation to launch?
Well, then we're getting pretty close, that's for sure, right? So really, it's getting electrical connectivity with the spacecraft. That's one of the things that we're going to be doing and getting ready prior to going into the countdown to make sure that the spacecraft team can talk to their spacecraft from a telemetry perspective, get the health, make sure the battery charging is at the appropriate levels. That's one of the major items. And then also all the vehicle preps that happen in the Falcon 9, making sure obviously the commodities are ready. We're going to load those obviously a little bit later, right before countdown, but and then they'll end up doing all the pad clearing operations and all those kinds of things to get everybody to vacate the pad. And about 3.5 hours before we lift off, the NASA team, the SpaceX team, we're all going to come on console along with the spacecraft customer and really get ready to run through the countdown procedures and do all the readiness polls, and then step into cryo load at about an hour before launch, but really start flowing the propellants about 45-50 minutes before we get into that launch phase.
Well, Jason, it sounds like you are well into your new position as a branch chief with LSP, and we thank you for coming on the show today, and we look forward to a successful launch.
Oh, well, thank you. Looking forward to it.
All of us are.
Yes,
absolutely.
Definitely. Goes well.
Everybody, thanks for joining us on NASA Edge today. Make sure you tune in to NASA TV for further coverage of the SWAT launch, and you're watching NASA Edge, an inside and outside look at all things NASA.